I'm your host, Grayson Pulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends mobility with leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Dr. Adarsh Ayyar, Director of Technology, Combat Mission Systems, BAE Systems. On today's episode, we'll explore how digital engineering, AI, and software-driven architectures are redefining combat missions. We hope you enjoy this episode. Adarsh, welcome to the podcast.
Thank you so much, Grayson. It's nice to be here.
It's great to have you here. BAE plays a critical role in the industries that you serve, and we're going to talk about the defense industry today. And I read a lot, and I'm going to put my curiosity hat on here to begin. In your opinion, how is AI and autonomy changing combat?
It's definitely changing, and I'll give you two perspectives. One from the perspective of the end capability, because at the end of the day, everything we do is to give some capability to the warfighter to defend us. That's our goal, right, as a defense company. So in terms of how do you enhance that capability, the end product that we give our warfighters, AI and autonomy plays a role there in giving that soldier that capability, the warfighter that capability. Think of it in terms of these bomb disposable units that have this autonomous robots that go, they're disposable. So similarly, we want to make sure our warfighters, we mitigate the risks for them as much as we can through our products. So that's why we leverage autonomous solutions. So if a warfighter does not have to be in a high-risk situation and there's a solution for that, a technology solution for it, our goal is to get that to the warfighter so they can leverage that. So they can stay further behind maybe, or make decisions using these autonomy AI systems so they don't have to actually go closer to the threat. So that's one way. The other way I would say is in our processes of technology development to get that capability in the soldier's hand, in the warfighter's hand, right? So one is the end capability I spoke about. The other is the speed at which we can go now because of these tools to help get that capability, help defeat the threat, help develop the technology faster, better, predict risks better, and things of that nature. So those are the two perspectives AI and autonomy has been playing in the defense area.
I mean, we can all say, and our listeners will agree, we've come a long way since the original military's leader-follower program, where it seems prepping for this podcast that AI and autonomy is through all branches of the service, not just limited. Is that what you're seeing from the BAE side?
Yes, absolutely. It's in all branches and it's actually at multiple levels. So we generally don't think of AI. You think of the robots walking around doing something, shooting. That's more dramatic, right? But for us, AI and autonomy is more important, for example, in terms of reducing crew burden. There's a lot of sensors, a lot of stimuli that's in a combat vehicle these days. So how do you help that warfighter make decisions quickly, not overload with all the sense information? So actually, autonomy and AI is used a lot there in terms of aided target recognition, in terms of helping the crew reduce their burden, mission planning, for example, giving recommendations. Think GPS system. When is the last time you looked at a map, right? You plug in the address, you sit down, and then you just follow the instructions. So that's your burden that's reduced. Now you can focus on the driving, not have to worry about navigating. So that's a simple example. Similarly, we have systems for the warfighters as well to reduce that crew burden.
If you look at going back to the original leader-follower program, there was a lot of feedback that the Army has declassified over time with the feedback that they learned from that program. As BAE is developing systems, are you getting input from war fighters or from the various departments because they're actively out there using it and said, well, sir, if you do this or you add this, we can see a 10x increase in safety or 10x increase in performance? Are you gathering that feedback and incorporating that into what you're building?
Yeah, actually, that's critical to our development process. So we have multiple touch points for the warfighters to come into our labs. We go to their labs as well. We work jointly in trying to understand what the capability can do for them. This has become more important in today's world because if you look at the past history, the Department of Defense would create requirements for a solution, and then the requirements would go out, we would bid on it, we would create the product. That's a 4 to 7 year life cycle you're looking at. with the way the threats are evolving because of this rapid technology development pace, we have to come up with different strategies that are equally fast or faster. Okay. And in order to do that, we jointly work with the soldiers, the sailors, Marines, war fighters, all of them, and even the administrative side to manage requirements and things like that. And we incorporate this feedback into our products so we can make better products. That's the constant, that's the loop that we have, a human in the loop.
So you have the human in the loop, but would you say the accelerant or the gas is allowing you to stay ahead is software?
I think digital engineering, digital engineering, what it does is it gives you the ability to simulate environments rapidly at a very low cost. Okay, you'll never get rid of the physical testing. That's important. That's important to validate the models. That's important to give you that confidence that your product's going to work. But what digital engineering does, what modeling and simulation, an element of digital engineering does for you, is gives you the opportunity to mitigate the number of physical tests needed and explore a trade space that you probably could not have done. Cost aside, sometimes the real world limitations exist and you can't explore all those scenarios. But in a digital environment, in a synthetic environment, you could run thousands, 10,000s of scenarios, snow, ice, wind, night, day, doing that. So that ability to do that quickly does two things for us. Once, it helps with the pace of development of the technology, the capability we are looking to develop. And secondly, it helps us understand the risks and mitigate and left shift that whole cycle earlier. So those are the two main advantages, I would say.
If you use let's call it the software engineering term, the common term is stack. Oh, the software stack has this, it has that. And let's use the warfighter. I'm going to call it the combat stack. When did digital engineering enter the warfare combat stack?
Now, digital engineering has become a buzzword lately, and that's partly why we're here. But what you may not realize is that we have dabbled in elements of digital engineering for more than 2 decades. When you think of modeling and simulation, physics-based modeling and simulation, in the simplest terms, a CAD model is a digital twin. It represents the geometry of a physical asset. Okay, digital twins are much more sophisticated today. We have other attributes, system parameters built into it. But when you think of it that way, that's the digital twin in its simplest form, right? So think of how long we've been doing CAD models. We even have sophisticated physics-based models, the ones that help us do, for example, survivability testing, mobility testing, lethality testing, computational fluid dynamics for our vehicles that can swim, or for projectiles that can travel long distances. So we have been using these tools for 30 years. So these elements have actually been there. What's happening now is the ability to actually connect that ecosystem. We have the tools, the information sits there, the models sit there, then you have the CAD model that's in a separate software, it sits somewhere. The ability to start connecting all of that all the way into your prototyping, rapid prototyping, manufacturing, supply chain. That's the digitization of the entire engineering process. But the elements have already existed for many years.
You're right. I remember, I think it was middle school, probably about 30 years ago, when they tried to show us CAD. It was over my head. I was like, yeah, I can build something with wood with a CAD. And then if you look at how far it's come, and if you want to call it, use the term digital elements, because they're all part of our life. You watch TV, you make your coffee. It's all touching a digital element. But defense has security as a major issue, that you have to ensure security across everything that you build and that you deploy. Which raises the encryption question. How do you make sure with all these intricate systems that have mission critical data, is what I'll call it, that are, one, they're secure, and two, they're highly encrypted?
Well, first and foremost, even in our combat vehicles today, and for the last 20 years, there is access to data at different levels, unclassified and classified. Maybe the commander gets to see the classified screen. Not every warfighter gets to see the screen. So we have had to deal with that for many decades. So we have been dealing with that. As you mentioned, there's more data coming in, so the need for security is becoming more and more. One of the reasons we just can't take something that's commercially available and slap it on has to do with security. We talk about hardening our systems, whether it's a commercial hardware or a software, cyber hardened. It needs to be cyber hardened. And sometimes certain commercial solutions simply won't work for us because the underlying architecture is not secure enough. So the fundamental basis of it, if it's not secure, we can't use it. So there are multiple security protocols. And the key there, Grayson, I would say, is that multiple protocols. That's the key. You think of two-factor authentication. Yeah, you can have a password and a login and you can get in. But these days, you also get a text on your phone with a code. So you put that in, right? That's just two-factor authentication. So we use multi-factor authentication to, for example, in our vehicles, as soon as you start it all, there is a process it goes through to check that everything in there is supposed to be there and someone didn't accidentally replace something or intentionally replace something. So it's called handshaking, where it talks to each other and makes sure, yep, you're supposed to be there, I'm supposed to be here. So we have these protocols already in our platforms so that when you turn the systems on, they go through that and make sure that everything that's in there is supposed to be there. And if it's not, you get notified right away.
Are you incorporating biometrics yet into the system security architecture?
Not yet. Not in the platforms or solutions that we have yet. Obviously, it can be done. It is common even the commercial side. The solutions that we are working with right now, we haven't implemented that.
So, but it's something that you can obviously look at. So this is a forward-looking question because I've been reading a lot of, these are still scientific papers I want to mention to the audience and to you. I've been reading a lot about quantum computing. And there are some scientific papers that say quantum has the ability to break certain levels of encryption. I'm not a scientist, so I can't tell you what levels. I'm just telling you that's the takeaway that I have from some of these scientific papers that have been published on it. Are you monitoring for new and emerging risk like that? To say, okay, the system is secure to the standard today, but in the future, potentially based on what's coming in the labs, we got to test for that. Are you monitoring all of that?
Yes. We have a cybersecurity team there. Their job is cybersecurity. They are some of the best engineers that in that area. So we are constantly looking to make sure how we can defeat our own systems. That's part of our job. That helps us get better. So that's the team that tries to attack and take down a system. And so there's two groups that independent that can test the system. So that's one in terms of the existing security protocols. And then, of course, we also work with the Department of Defense jointly on understanding what's coming next in terms of the threats that they are seeing globally that we may need to be aware of. So we get briefed on that. And that's how we come up with solutions for these emerging threats, that may be in the horizon.
You hit on something, and for the audience, I just want to highlight this. It's a collaborative relationship. Is that a fair statement to say between the Department of Defense and BAE?
Absolutely. Yes. We are partners, and that's the way it works. So we have to be, because we have to help. If you think of it, I may have a solution, and there may be a use for it. The Department of Defense may find a use or application for that if they understand what the technology can do. Right. And sometimes they have, because they are in the battlefield, they see that more. So there's this constant back and forth between us to develop the technology, develop the products, and defend national security.
Because when you have collaboration, no matter what industry, and if you're in the defense industry or if you're in the private sector as a civilian, really good things have happened, and you can jointly accelerate development. You've stated many times very publicly that data is the key. And the BAE Systems, you have 4 decades of data. I was like, wow. For multiple real world conflicts, how are you using that data? What is declassified that you can talk about from a modeling perspective that you've done or that you're ongoing with that data?
Yeah, there are multiple examples of that. So we have 4 decades of data, not just in our design and development of the different iterations of our vehicles, for example. Pick Bradley, right? Bradley has gone through a few different iterations. So we have the design and development data of that. So there's that data. But then Bradley has been deployed across the world in multiple battlefields a number of times. And there's data coming from real world That's what I mean by the real world data that comes back. And we get that data. So we can then compare it to our models, correlate to our models, improve the fidelity of our models so that they can better predict. And like I'll give you one example is we have models for the soil conditions pretty much across the globe. Okay, and working with the Department of Defense, we have that information. What do we do with it? We can predict how our vehicles through the models are going to perform in different parts of the world because we have the soil conditions. We know how they should be driven. We know when they will get stuck and what we should not do, which is equally important. That's an example. Another example is if you think about sticking with the terrain and the vehicle moves a lot, we have a weapon on top of a vehicle. There's a relationship between the vehicle's vibration and that weapon that we have to understand so that we can accurately fire a projectile, especially when you're talking long-range precision fires. Every vibration matters. So we model all that information, both on what we see, the vibration in the vehicle, we can track that, what we're getting from the terrain, that information goes in. And then our own systems have vibrations as well that can be captured. And that's how we analyze an entire system to increase that accuracy and predict and mitigate these risks.
As somebody that geeks out on data in their free time, I think that's super cool. So I'll say that for the record. I think that's super cool. But as building data models in my free time, that's not all data is created equal. So how do you ensure high quality data collection? And how do you ensure proper retention so you're not putting, I'll call it a not great piece of data into the model? Like, wait a second. How do you ensure that it's consistently high class?
That's a really good question, Grayson. And having the data and then starting to connect the data is two different things. Because now when you start connecting the data, the fundamental assumption you're making is that single source of truth, authoritative source of truth, that whatever you're relying on is good, and now I can make my assumptions and predictions based on what I started off with, right? So we do have processes in place for data collection and retention. There's established collection process, there's quality assurance process for the data to make sure that the data we're putting into the system is actually a good quality data. There's compliance and retention policies, how often they have to be checked, how long they have to be kept. There's quality metrics we use in the data to help us understand what the quality of the data is. So, and there's of course backup and recovery. You don't want to lose the data either. So these are all different parts of the whole data collection and retention process that we have, and we have a team that does that.
Well, since you work in it's called a secure environment, your servers, I'm assuming, have to be air gapped. I'm assuming all the software you have to write is probably written on-prem as well. Do you have teams of data scientists that are writing these algorithms to help advance your models and being done all in-house in a secure environment?
Yes, they are in secure environments, and some of our secure environments are actually connected. So we have teams across the country that can talk to each other, that can share models, that can move models from one system to the next system where it needs to be analyzed in a different environment, for example. So we do have ability to transfer the data securely and make sure the other side can get it and use that data as well.
Wow. Well, that's impressive, because I just thought it was like, okay, hi, you have to stay in here. And if you want to work on the model, you got to hop on a plane and come into this secure facility.
If it's a classified data, then there are more restrictions, and you have to be in a certain environment to do that. But even there are ways you can talk to other secure locations.
And is there, since you have the ability to talk remotely to secure locations, let's say secure location A to secure location B, have you seen any dramatic acceleration in terms of a project to being able to, if you wanted to use the term, securely, remotely collaborate together?
Yeah. And when we build the digital environment, one of the advantages you have in the digital environment is the ability for people to access parts of the model, to either get information from it or input information into it to build that model. And having different teams across the country be able to log into a single model and do that is of value, right? So you're not waiting to transfer something. They don't have to be on site to do that. And so that adds value as well in terms of how quickly you can develop things.
And staying on the secure environment theme, is it fair assumption to think or to believe that you're running your data centers like a BAE data center on-prem somewhere that's fully secure, and that's what's operating all this? You're not using your widely known cloud operators?
That's correct. So we have cloud-based environments, but they are our cloud-based environments. So they're securely. There's multiple locations where it's on premises, but some multiple locations. Again, both from latency, having information go across the country, large amounts of data. Also for security purposes, for backup and retention practices. You don't want everything in one area. So they're distributed network that's ours, that we manage, we control. The security protocols are all top-notch Department of Defense protocols that we also have to follow, obviously.
That's wonderful. So the company BAE has integrated the modular open systems approach. Well, what has that unlocked for you?
Yeah, so the modular open systems approach, that actually is a DoD mandate for all new programs. So that came out a few years ago, where for any new program, the DoD is mandating that. The reason it works for us is we are a system integrator and an OEM, right? So when you think about how long we have supported our customers, our war fighters, and the Department of Defense in general, technology has changed, and technology will change, right? that I can guarantee you today. So what we're talking about today will be different the next time you and I speak. So things will evolve. What the modular open system architecture does is it gives you the ability to have capability that you can add into a system quickly without having to tear up the entire system and then rebuild it, okay? So our traditional platforms, they are not built that way. They are LRUs, line replaceable units. So a single capability, it can do only that thing. It's all, you replace one thing, you have to change out the whole system. But modular open systems approach has architecture where you can take things out, pull things out. And if you have ever built a computer, desktop, Grayson, you were probably using some elements of modular open systems approach, where you could add the RAM, remove the RAM, as long as it had the right specification. It didn't matter which company you bought the RAM from, you could go stick it in there. That's an example of MOSA. So you can increase the RAM on your computer. That is an example of MOSA. So think of that in our platforms of how we do that. And in digital engineering, it's important as well, because when you just think of BAE Systems, we are a large company, right? And we have multiple business units that have disparate systems. And within a single business unit, finance might be using something else, supply chain might be using something else, engineering uses a different system, right? So trying to get everything under one system is cost prohibitive. It's not going to happen. And that's why we focus on digitizing the right things. And so then we have to figure out, how do we give ourselves the ability to bring in these disparate systems? It's a federated model is what we have in our digital engineering environment. That gives us the ability to take someone else's module that may not be in our language, in our software, translate it, and still use it in our environment. And you'll think of it, so just within BAE, but now think of what we have to do for our Department of Defense customers. They could have different systems too. We need to be able to talk to that, right? Information has to go back and forth. And then also in the supply chain side, as suppliers, a lot of the technology comes from them. We are system integrators. So they could have different systems than ours. So that's why the modular open systems approach, even as an OEM, is extremely important to us. And of course, it's important for the Department of Defense as well.
You have 4 decades. So how do you pick the right things to digitize? Is that a board level decision? Is that a chief scientist decision? How are you picking what to digitize?
That's a very good question. I'll give you one example. When you think of our combat vehicle, you think of the propulsion systems, the engine, the suspension, all of that, right? And there's some brains that's driving that. There's controls of that. Now, that's not rapidly changing in our vehicles, okay? They are fairly stable. So now let's look at a system, a counter UAS system, a counter unmanned aerial system that's there to defeat drones, for example. Guess what? That's a system that changes weekly, because the enemy gets smarter, they change the drones, they do things differently, and they're going to attack you in a different way. So when you think of how do you digitize the right thing, Maybe I don't want to digitize my propulsion suspension part of it because that's fairly stable. That's not where I need the rapid development. But my counter EOS system, it has to deal with this evolving threats constantly. So maybe I focus on that and get that digitized, which is exactly what we are doing to give us that added capability. And that capability can be upgraded quickly as well, right? So that's how we make decisions on what systems need to be digitized.
So evolving threats, you're right. So let's just say, I'm just going to use simple terms. Let's say on Monday, infantry A is out there, and then they come back. Well, the enemy on Tuesday figured, well, we're going to beat you on this. How fast can you push those software updates? Is that how it's this chicken and the egg game? Is it software updates to try and stay ahead, or what is it? Or do you actually send out physical hardware?
So the modular open systems approach is not on the battlefield today as it needs to be, at least on the Army's side. Air Force, Navy have implemented earlier than the Army. But that's why I said it's a mandate going forward for our programs. But all of us are still looking at how we take our legacy systems, for example, the Bradley, a combat vehicle, and start making elements of that modular so you can provide this capability and update it using software rather than relying on this one piece that has to be flown all across the world to go get that capability. So that's what we've already started looking at.
So when you're looking at that ties directly into life cycle management. Is that becoming a big part of the thinking as you're looking at existing products in the field and potential future products as they go in the field? So you're taking the modular open systems approach, but then also looking into life cycle management?
Yeah. And you actually hit on something, Grayson, there. One of the advantages that digital engineering and modular open systems architecture do for you is it gives you the ability to digitize the capability, for the example, like we spoke about, and then implement that even on a legacy platform. And now the platform gets more life because of that, right? So because you've given it an added capability that makes it more relevant in today's battlefield, and therefore you can use that. So it gives it this additional life. And then the separate part is as you get into digital engineering, and then I call it one more level up. It's the digital enterprise. So the digital engineering is just the digitization of the engineering processes. But when you think of the entire business at an enterprise level, hence digital enterprise, they both are DE. It's more about supply chain, production, operations, logistics. All of that starts to come into play as well, right? Into your ecosystem. And when you do that, the beauty of that is when it's all connected, you have the digital thread, your decision making becomes much, you can make smarter decisions faster, you can do more predictive analysis. And as your vehicles are out there or your systems are out there in the real world, you get data back to let you know when they need to be replaced. Just like you don't take your car for an oil change anymore at a set mileage. You do it when it tells you, it pops up and says, change oil, So that's the predictive maintenance part. It's predicting, right? So similarly in our world, that's how it'll work as well.
You have a really wonderful, elegant way of saying this. You envision us basically as a smartphone where the app's constantly getting updates. How did you come up with that metaphor? Because I was like, oh, I get that. It's simple. So we're just going to constantly update the vehicles. And if I'm a warfighter, I get that. Everybody has a phone. That's a beautiful analogy. How did you come up with that?
I just came up with it, I guess. I was trying to explain, when you think of our platforms, they have a lot of capability. There's cameras in them, sensors, radar, so many different, and we keep adding more and more. Traditionally, what we have done is we have looked at it as just for that function, okay? These cameras can do just that. It doesn't have to be that way. When you deploy a modular open system architecture, and now you have a software-driven architecture behind it, which is this phone you were just talking about, the phone has a camera. Depending on the app, your capability changes. You download an app, you point the camera at the stars, you're an astronomer. You download a different app, you point the same camera, same phone at the plants, you're a botanist. Another app, you can measure distance between two things. Nothing changed with the hardware, right? Now think of all the capability we have in a combat vehicle. Cameras, sensors, they don't have to be restricted for just that one function we originally designed it for. As we get information, the ability in a modular open system architecture, you can move information back and forth between the subsystems. And now that gives you additional capability that you probably didn't even think about when you started off your design. And that's why we are pushing for the software-driven architecture, because then we can increase the capability through software updates rather than relying on just the capability of that one system. You can all the sensors and radars, everything on your combat vehicle, you can use all of that to get you the solution that you want based on software.
When I look at a smartphone, I think the only limitation today is imagination, because it's going to keep getting better. But if I look at it from a military standpoint, I've toured all the academies and been to the war colleges, and it's a fascinating scenario, and there's appointees for several of them. Do you study that old history that the generals and the professors at the war colleges teach of different tactics and try and put that into the software? Because to me, if you go visit with the war colleges, there is this incredible depth of knowledge that I don't think you can get anywhere until you actually sit down with these professors or those institutions. It's like, wow, if I had that and I could digitize that, we could do a lot of wonderful things. Are you gathering any of that input as you look to build what you're building?
Yes. And, I go back to my comment about the data has a soul, right? So I'll use a specific example. I spoke about my technical fellows who are the senior most engineers in the organization. And the majority of them have more than 40 years of experience in this organization. A lot of what we do is not taught in schools and colleges because, that's a highly specialized field, and in most cases, it's sensitive information. So how do I take the information that my technical fellows have, my engineers, subject matter experts have, and make sure I just don't get the data part of it, but that soul of the data I was talking about? What does the data mean? How do you use the data? That knowledge is up here right now. How do I digitize that portion of it? So that's an exciting challenge for us right now where we do that. For example, in one of our modeling, so we have one of our subject matter experts who's a specialist in welding and manufacturing processes. We have interviewed him and gotten his knowledge into the software. So now when a junior engineer sits and starts saying that these two should be joined this way and he puts a weld, he'll get a notification on the saying that the weld is too close to this. You can't use this kind of welding. Think of a different kind. That's the knowledge that we have captured from the SMEs and we're putting it into these digital tools. That's an example. So your point about all that information from these generals, these experts that have fought, that needs to be captured as well. And that's something you can do in digital engineering, and that's an exciting part as well.
As a history geek, I'm truly a history geek, and this is this individual has passed away, but one of the greatest military leaders, especially for the infantry, was General George S. Patton. Imagine if we could have a digital replica of Patton's brain of what he did. Well, okay, yes, there's history books, but if there was somehow a way to digitize Mr. Patton's brain, I just think about what you're taking with all this war knowledge of General Schwarzkopf from Desert Storm, or all these great generals throughout it, or Eisenhower, just all these great generals through history. Is that, I'm going to sound weird, but if you somehow would take a digital twin of their brains, and it's institutional knowledge. And I can think about, with all the technology today, what that can allow you at BAE to build would be nothing short of fantastic. So this raises the question, Adarsh, with my little crazy vision in mind, what is the future of engineering for this industry?
You brought up one angle to look at it. Let me offer a different perspective. Essentially, the same thing that we want to do. I mentioned that I have a group of these senior most engineers. More than half of them have been with the company for 40 years. Okay. I know who to go to if I have to have a question on the Bradley torsion bar. I know exactly who to go to and probably get an answer within 30 seconds, right? So as we get into this next generation where employees in general, not just engineers, don't necessarily stay with the company for 40 years or 30 years or 20 years, or even 10 years, how do we create a system and a process that can capture the knowledge while they're there, not just take the knowledge and implement into our models, but even transfer it to them so that they can onboard quickly, add value in what they're doing, and they'll probably leave in 5 years, 10 years, whatever that might be, but it shouldn't disrupt us, right? So from that perspective, we are looking at tools, training tools, smart ways of getting that information in, and that's where autonomy and AI play a role as well to capture that part. So it's just a different perspective of what you brought up essentially.
But it's fantastic. You had one of the greatest lines I've heard in a long time. Data has a soul. Adarsh, this has been a fascinating conversation. As we look to wrap up for today, what would you like our listeners to take away with them?
It's exciting what's happening right now with autonomy and digital engineering. We already spoke about digitizing the right things, why that is critical. You're not just going to go off and start taking everything and turning to you because you don't need to, right? So we spoke about that. The other part I talk about is autonomy is a tool, AI is a tool, digital engineering is a tool. They're very powerful tools, but they rely on very creative engineers, and the data that it's using and the soul of the data we spoke about a few times here also relies on very creative, intelligent human beings. Let's not forget that. So I can't take a bad engineer, throw AI on top of that autonomy and somehow turn that into a good engineer, right? But I can give these tools to a good engineer to do great things. That's the way I look at it. And then so maybe that's one takeaway. We will always have a need for creative, intelligent, capable engineers and employees in general. These tools will give us the ability to enhance our creativity, but that fundamental need is always going to be there.
Tools are powerful, but behind the powerful tools are great engineers. Today is tomorrow, tomorrow is today, the future is BAE Systems. Adarsh, thank you so much for coming on SAE Tomorrow Today.
My pleasure. Thank you for having me.
Thank you for listening to SAE Tomorrow Today. If you've enjoyed this episode and would like to hear more, please kindly rate, review, and let us know what topics you'd like for us to explore next.
Be sure to join us next week as we dig into how a student-built solar car just crossed 3,000 kilometers of the Australian outback, powered only by sunlight. And you guessed it, they won the 2025 Bridgestone World Solar Challenge.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.